Imagine you are holding a physical object in your hand right now. It's light, it's flimsy, it's this square of black plastic, maybe about 5¼ inches wide.
Yeah.
And it actually wiggles if you shake it.
Right, the kind that actually flops.
Exactly.
Yeah.
The kind you have to handle with extreme care because if you touch that exposed magnetic surface right in the middle, you ruin absolutely everything.
Oh, yeah. You'd lose hours of work just from a thumbprint.
Seriously.
Yeah.
Now imagine this single piece of plastic containing just a few hundred kilobytes of data is essentially a weapon.
Yeah.
It's 1985, and this disk is about to walk up to the biggest software companies in the world.
The absolute titans of the industry.
Right, companies that were charging the equivalent of a used car for their programming tools, and this disk is about to absolutely humiliate them.
It really is the ultimate David and Goliath story. But in this version, David isn't just lucky. David has built a noticeably better slingshot, and he is selling it for absolute pennies while Goliath is still trying to fill out the paperwork to run a catapult.
I love that. So we are doing a deep dive today into Borland's Turbo Pascal 2.0. And look, I know the word Pascal sounds like something you learned in a dusty high school computer lab and then immediately purged from your memory.
A lot of people definitely have that trauma, yeah.
But the story here isn't really about the syntax of a programming language.
Yeah.
It's about the moment software development stopped being exclusively a rich man's game.
Exactly. It's the exact moment the developer experience, or, what we call DX today, was actually invented. Because before this disk arrived, programming was literal manual labor.
Yeah.
And after this disk, it was something else entirely.
So to guide us, we have a really fascinating primary source for this deep dive. It's a screen-test review by a writer named Tanj Bennett. This was published in the Vintage Computing magazine right in the heat of 1985.
Such a great snapshot of the era.
It really is.
Yeah.
Bennett was reviewing Turbo Pascal 2.0 on a Series 1 computer running MS-DOS, though, it was also available for CP/M machines.
Mm-hmm.
And the vibe of this review, it isn't just this is good software. It's more like the world has just fundamentally changed.
You can actually feel the shock in his writing. He's looking at the price tag, he's looking at the performance, and looking at the competitors, and the math just does not add up for him. He's highly suspicious.
Let's start with that math, actually, the price tag. Because I think today in 2026, we are so used to software being free or just a cheap monthly subscription. But set the scene for us in 1985.
Sure.
If I wanted to be a serious programmer, not a hobbyist tinkering with BASIC, but a professional building real applications, what was I buying?
You were buying Microsoft Pascal. That was the gold standard back then. That was what the serious businesses used. And for that privilege, you were paying around $300.
Wow.
Now you have to plug that into an inflation calculator to really understand the pain there.
Right. So in 2026, money that is roughly $900.
$900. Just for a compiler.
That is insane.
It's a massive barrier to entry. If you were a kid in your bedroom or a college student or just a hobbyist with a PC, you were not buying Microsoft Pascal. It was an enterprise tool. You had to convince your boss to buy it for you.
And then Borland, led by the legendary Philip Kahn, drops this Turbo Pascal disk. And the price is $49.95.
Which is about $150 today.
That is, it isn't cheap like a cup of coffee.
Yeah.
But compared to $900, it's an impulse buy. It's the difference between buying a high-end racing bicycle and buying a Honda Civic.
Exactly. It completely democratized the tool set.
Yeah.
But, and this is the core of our deep dive, usually when you buy the bargain bin version of a professional tool, you expect it to be garbage.
Right.
You expect it to be a toy.
You buy the knockoff power drill at the discount store. It smokes and dies after driving 3 screws. You get what you pay for.
Precisely. And Tanj Bennett's review starts with this exact skepticism. He is asking, what is the catch? He assumes there has to be one. But as he digs in, he realizes that the $49 disc isn't just a cheaper alternative. It is actually a superior paradigm.
And he frames the entire computing world of 1985 as a war between two hostile camps, right? The interpreters and the compilers.
Yes. This is a crucial distinction to understand why Turbo Pascal was such a massive deal. We need to define these terms because we totally take them for granted now.
Yeah.
In 1985, you had these two distinct tribes. Let's start with the interpreters. This was basically BASIC.
Right. If you turned on a Commodore 64 or an Apple TSIC, you're instantly dropped into BASIC. BASIC is an interpreted language.
What does that actually mean for the machine, though? Like, what is happening inside the actual box?
So imagine you are giving a speech at the UN, and you have a simultaneous translator standing right next to you. You say a sentence in English. The translator listens and thinks for a second and speaks it in French. Then you say the next sentence. The translator listens, thinks, speaks.
So it's line by line.
It's completely real time. The computer looks at line 10, figures out what it means, runs it. Then it forgets, it moves to line 20 and figures out what that means, runs it.
So the interpreter is just a program that sits between my code and the CPU translating on the fly.
Correct. And the big advantage is friendliness. If you type print, quote, hello, unquote, and hit enter, it happens immediately on the screen. If you make a mistake, it stops right there and tells you. It's highly interactive. It's fantastic for learning because the feedback is instant.
But the downside
Is that it's agonizingly slow because the computer is spending most of its time translating, not actually doing. If you have a loop that runs 1,000 times, the interpreter has to retranslate that exact same line of code 1,000 times. Doesn't remember that it just did it. It has zero long-term memory.
So BASIC is the friendly but slow lane. Now the pros were using compilers, Microsoft Pascal. How is that fundamentally different?
A compiler is more like translating a full book. You write the entire manuscript, the source code, you hand it to the translator goes into a room, locks the door, and spends 6 months translating the whole thing into a new language, which is the machine code.
And while they're in the room, I'm just standing outside waiting.
You are waiting. And in 1985, you are waiting a really long time.
Walk us through the workflow of that. Let's say I'm a developer in 1985 using Microsoft Pascal. I want to write a basic program that says, hello world. What do I actually physically have to do?
Okay, brace yourself for this.
Yeah.
Step 1, you load your editor program. You type the code. You save it to a floppy disk. Step 2, you exit the editor. You physically pull out the editor disk from the drive. You insert the compiler disk. You run the compiler.
No, man.
The compiler reads your source file from the disk, churns for a while, and spits out an object file onto the disk.
Is that the program? Can I run that object file?
No, that is just a fragment.
Yeah.
Now you need step 3, which is the linker. So you take out the compiler disk, you put in the linker disk. The linker takes your object file, combines it with system libraries like how to talk to the screen or the keyboard, and stitches them together into an actual executable file.
And then finally I can run it.
Then you can run it. That is the infamous edit, compile, link, run cycle.
That sounds absolutely exhausting. Just listening to you describe it is exhausting.
It is worse than exhausting. Suppose you run it and you realize you forgot a single semicolon on line 5.
Oh, no.
Oh, yes. You cannot just jump in and fix it. You have to reboot the editor, load the file, add the semicolon, save, exit, load the compiler, compile, exit, load the linker, link, run.
So a simple typo could cost you 5–10 minutes of disk swapping and just waiting around?
Easily. This is why professional programmers in the 80s were so incredibly disciplined. You had to be. You couldn't afford to debug by trial and error like we do today. You had to dry run the code in your head, literally simulating the computer in your brain, because the penalty for a careless mistake was 10 minutes of your life listening to a floppy drive grind away.
So the stark choice in 1985 was, do you want the friendly instant gratification of BASIC, but your program runs like molasses? Or do you want the blazing speed of a compiled program, but the development process makes you want to pull your hair out?
Exactly. Easy and slow or hard and fast.
Yeah.
Those are the two buckets. And nobody thought you could bridge them. They were seen as just fundamentally different technologies.
Enter Borland.
Enter Turbo Pascal. Bennett, in the review, explicitly calls it a compiler that acts like an interpreter.
How, though? Is it just black magic?
It really felt like it to people at the time. The secret sauce, the thing that blew everyone's mind, was how it handled memory. Traditional compilers like Microsoft's were designed for older machines with very little RAM. So they did everything on the physical disk. Read from disk, write to disk. And disk access is incredibly slow. It's mechanical.
The read-write head physically has to move across the magnetic platter.
Right. Borland took a look at the IBM PC and the Sirius 1 and said, you know what? These machines have 128 kilobytes of RAM. That is actually enough to hold the entire compiler, the entire editor, and your source code all at once.
So it never touches the disk?
Almost never. When you hit compile in Turbo Pascal, it grabs your source code directly from RAM, translates it to machine code, and writes it to a different part of RAM.
Yeah.
It is all just electrons, no moving parts whatsoever.
The review mentions speed metrics on that Sirius 1. What kind of numbers are we actually talking about here?
Bennett clocked it at 2,500 lines of code per minute.
2,500 lines a minute.
Yeah, that's over 1,000 characters per second. In 1985 terms, that is instantaneous. It meant that for a typical small to medium program, you hit run, and it just starts running instantly. The compilation happens so fast, it is practically invisible to the user.
So for the user, it feels exactly like BASIC. You type, you run. but under the hood, it is generating raw, blazing fast machine code.
It was the ultimate have your cake and eat it too moment for the industry. You got the development speed of an interpreter with the execution speed of a compiler. And frankly, Microsoft didn't know what hit them. They were selling a tractor, and Borland was selling a sports car that could also comfortably plow a field.
This concept where the editor, the compiler, and the runtime are all bundled into one program, we have a specific name for that now.
The IDE, the Integrated Development Environment. Turbo Pascal is widely considered the grandfather of the modern IDE. Before this, a development environment meant a messy desk full of 50 floppy disks. After this, it meant a single, cohesive piece of software.
Let's talk about that environment, because Bennett spends a lot of time in the review discussing the actual user experience, and it starts before you even write a single line of code. It starts with installation.
Yes, a little program called Tinst Turbo Install.
Which doesn't sound very exciting, but the review treats it as this major killer feature. Why is that?
Because the hardware landscape in the 80s was a deeply fragmented mess. Today, you write software for Windows or Mac OS, and it mostly just works across all monitors and keyboards. Back then, you had the IBM PC, the Series 1, the DEC, Rainbow, the K-Pro, and they all handled screens and keyboards completely differently.
So if you bought a generic compiler, it might not even know how to clear the screen on your specific brand of computer.
Exactly. Or the arrow keys might not respond. Or the delete key might print some weird graphical character instead of actually deleting. Tinst was this brilliant utility that let you customize Turbo Pascal to your specific weird hardware. You could tell it when I press this exact key, do this specific command. You could even choose your screen colors. Bennett noted there were over 20 terminal types supported out of the box.
It's Borland showing an immense amount of respect for the user. They're saying, we know your setup is unique here, is a tool to make it work seamlessly.
And the interface itself was incredibly snappy. Bennett mentions single keystroke menus.
What does that mean in this specific context?
Instead of typing out a full command like compile or edit into a blank command line, the menu just listed options with one highlighted brightened letter. E for edit, C for compile. You hit E and bang, you are instantly in the editor. Because it's all sitting in RAM, there's zero loading time. It was entirely fluid, as fast as the screen could be written.
Speaking of the editor, Bennett describes it as WordStar-ish. Now, I know WordStar was a popular word processor, but for our listeners who weren't drafting novels in 1982, why is that detail so significant?
WordStar was the absolute gold standard for typing text on a PC. It used these very specific control key combinations like control key D to save or control QF to find text. They were completely arbitrary. They made absolutely no logical sense, but everyone had them memorized. It was deeply ingrained muscle memory.
Sort of like Control C and Control V today for copy and paste.
Exactly. If you released a text editor today that didn't use Control C to copy, people would riot. They simply wouldn't use it. Borland recognized that exact dynamic. They didn't try to invent their own clever proprietary way to move the cursor around. They just copied WordStar. If you knew how to type a letter to your grandma, you already knew how to write code in Turbo Pascal.
However, there's one feature in the editor that Bennett points out, and it sounds just bizarre. He calls it a quirk, but I think he is being very polite. It's about the tab key.
Ah, yes, the dynamic tab feature. This is a genuinely great example of 80s software design, where engineers tried to be overly helpful and just ended up creating total madness.
In every text editor I have ever used, a tab is a fixed space. You hit tab, the cursor jumps 4 spaces or 8 spaces. Very simple.
Right. In Turbo Pascal's editor, hitting tab didn't jump a fixed distance at all. It jumped to a line with the start of the next word in the line directly above it.
Wait, so the behavior of my tab key entirely depends on what I just typed on the previous line?
Yes, it is totally context dependent.
That sounds incredibly chaotic. Why would they ever design it that way?
It was intended specifically for formatting coding layouts.
Uh-huh.
Imagine you were writing a list of variable declarations in Pascal. You have var, then name:*string, then age:*integer. The idea was you type the first line, then on the second line you hit tab, and the cursor jumps exactly to where the word name started. You hit tab again, it jumps perfectly to a line with the colon.
Okay, I can sort of see the logic there for making nice, neat columns of code, but what if I'm just writing normal procedural code? Or a long comment?
Then it is an absolute nightmare. Bennett calls it exasperating in the review. If the line above is empty or just has a random comment, your cursor is flying all over the screen completely unpredictably. You are just pressing tab and praying at that point.
And the absolute best part is the irony Bennett spots in the official documentation.
He checked the example code provided by Borland on the actual disk, and none of it uses that column-style layout. So even the engineers who built the feature didn't actually use the feature in their own examples.
Classic software engineering right there. We built this cool thing. Did you use it? No, it's super annoying.
But despite that weird tab behavior, the editor had this killer app feature that I think probably sold more copies of Turbo Pascal than the cheap price tag did. Error handling. We talked about the nightmare of the Microsoft Pascal error loop earlier. You compile, it crashes, you get a cryptic numerical code, you have to go backload the editor and hunt for the line. How did Turbo handle that differently? This is the true DX revolution. In Turbo Pascal, you hit run. If there is a syntax error, say you missed a standard semicolon, the compilation stops instantly. The editor reopens automatically, and the cursor is blinking exactly at the exact spot where the error happened in the source code.
It literally takes you straight to the crime scene.
Instantly. You don't have to write down line numbers on a notepad. You don't have to search. You are just there. You type the missing semicolon, you hit run again. The feedback loop went from 10 minutes to 10 seconds.
That flow state, that is what modern programmers are always chasing. Being able to stay deep in the problem without being interrupted by the friction of the tool.
Exactly. Bennett does mention that to get the full English error messages like missing semicolon instead of just error 85, you had to load a separate error file into memory, which was optional. But even without that text, just being physically positioned at the error was an absolute revelation. It made programming feel like sculpting wet clay rather than baking a cake. You could reshape it constantly and get instant results.
I want to pivot to the deep dive technical side of things now. We keep saying it runs entirely in RAM, and we mentioned these machines had maybe 128K of memory. But the review drops a number that genuinely shocked me. It says the entire Turbo Pascal environment fits in 50 kilobytes.
50K.
My smart toaster has more buffer memory than that. A single screenshot on my phone is 5 megabytes. That's 100 times larger than this entire development suite.
It really is testament to how bloated modern software has become. But back then, 50K was tight, but it was manageable. However, this incredible efficiency came with a very hard ceiling. We have to talk about the 64K barrier.
The 64K barrier, this is intrinsically related to the 16-bit architecture of the chips of that era, right?
Where the Intel 8086 processor addresses memory in segments of 64 kilobytes. It is kind of like looking at a massive book through a tiny cardboard window that can only show one page at a time.
So Turbo Pascal lives in RAM, my source code lives in RAM, and the actual program I am compiling lives in RAM.
And they're all violently fighting for that limited space. The review highlights a very hard limit. Your source code text file cannot be larger than 64 kilobytes.
That is not a lot of code. Maybe a few thousand lines at most.
If you're verbose, maybe 2,000 to 3,000 lines. If you try to write a massive application in one single file, Turbo Pascal will just throw an error and say memory full.
So what if I want to build something real? A full word processor? A database engine? Those are way bigger than 64K.
You had to use workarounds.
Yeah.
Bennett discusses this concept of include files. Essentially, you chop your giant source code into smaller, separate text files, and the main file just says include file A, include file B. The compiler stitches them together dynamically during the compile phase.
Okay, that elegantly solves the source code text limit. But what about the compiled program itself? The binary thing I am actually building. Is that limited to 64K too?
Yes, it is. And this is a much bigger structural problem. The resulting the .com file can only be 64K.
So I literally cannot build a large complex program with Turbo Pascal 2.0.
Not a monolithic one, no. You had to use a technique called overlays.
Overlays. I've heard this term thrown around by old school hackers. It sounds terrifying.
It is terrifying. Imagine you are memorizing a long play, but your brain can only hold Act 1. So you memorize Act 1, you perform it on stage. Then while the audience is clapping, you completely forget Act 1 and frantically memorize Act 2.
That sounds incredibly risky.
In computing terms, it meant your program would run. Then hit a pause, go to the floppy disk, load the next chunk of code into the exact same memory space, overwriting the previous chunk, and then continue executing.
So you, the programmer, had to manually manage the brain surgery of your own application while it was running.
You had to structure the entire app around these physical disk swaps. You had to think, okay, the user's going to the print menu now. I need to drop the edit code from memory and load the print overlay from the disk. It was highly tedious and it was slow because you were suddenly hitting that mechanical disk again.
And this naturally brings us to the output format. You mentioned .com files, but when I think of classic DOS programs, I always think of .exe files. What is the fundamental difference there?
This is a key technical trade-off Borland made. A .com file is very simple. It is a raw, contiguous image of memory. The operating system just takes the file, dumps it directly into RAM, and jumps to the very first byte. It is extremely fast to load, but it's totally rigid. It can't easily span across multiple 64K segments.
And an exe file.
An exe file is smart. It has a complex header that tells the operating system, I need this much memory over here and this much memory over there. It can be relocated anywhere in RAM. It can be huge. Microsoft Pascal produced these smart exe files. Turbo Pascal 2.0 could only produce the simple .com files or CMD files for CPM86.
So that is the real catch. You get the fast, cheap compiler, but you are securely trapped in what they call the small memory model.
Exactly. And there was another huge limitation tied to that. You couldn't link to outside libraries. If someone wrote a really cool high-speed graphics library in C or an assembly language, you couldn't just link it into your Turbo Pascal program. You were completely isolated on an island. You were stuck inside the Turbo ecosystem.
So for a massive enterprise application spanning hundreds of thousands of lines, Microsoft Pascal was genuinely still the better architectural choice.
Structurally, yes. But Borland was making a very calculated bet that 90% of the software people wanted to write didn't need to be massive. It just needed to get written quickly.
Which brings us perfectly to the showdown. Bennett's review actually runs formal benchmarks. This is the real David versus Goliath moment. We have the $49 Turbo Pascal directly up against the $300 Microsoft Pascal 3.11.
And the results of these benchmarks are surprisingly nuanced. I think people retroactively expect Turbo to just win absolutely everything, but it definitely didn't.
Let's look at the compilation speed first, since we already know Turbo is fast.
Turbo compiled the entire benchmark suite in about 304 seconds. It was blindingly fast compared to Microsoft. And Bennett is very careful to point this nuance out. When they measured the execution speed of the final compiled programs, Microsoft actually won. Microsoft's compile time was 263 seconds for execution.
Wait, so the program created by Microsoft Pascal actually ran noticeably faster than the program created by Turbo Pascal?
Yes, the Microsoft code was faster.
Why is that? If Turbo is so incredibly fast at the compiling part, why is the end result slower?
Because, honestly, Turbo is dumb.
Dumb seems like a pretty harsh word for a genius piece of software that redefined the industry.
It is technically dumb. Turbo Pascal is what's known as a single-pass compiler. It reads your line of code and instantly translates it to machine code. It doesn't look ahead, it doesn't strategize, it just blindly translates line by line.
And
Microsoft Pascal is a multi-pass compiler. It reads your code, builds a complex mathematical model out of. It analyzes the loops, looks at the CPU registers and says, hey, I can optimize this. I can move this variable into a fast hardware register so the loop runs in half the time. It takes much longer to compile because it is actually thinking.
So Microsoft is the tortoise that plans the route carefully. Turbo is the hare that just sprints in a straight line.
And the direct result is that Microsoft's final machine code is tighter and faster. Also, crucially, Microsoft supported hardware math.
Ah, the 8087 coprocessor.
Exactly, the math chip. In the 80s, the main CPU was notoriously bad at floating point math, handling decimals. You could buy a totally separate physical chip, the 8087, just to handle the heavy math.
Yeah.
Microsoft Pascal could detect and use that chip. It gave you 15 digits of mathematical precision.
And Turbo.
Turbo Pascal 2.0 did all the math in software. It simulated the math using the main CPU. That is much, much slower. And the review specifically notes it only had 11 digits of precision compared to Microsoft's 15.
So if you were doing heavy scientific calculations like trajectory plotting or structural engineering, Turbo was actually a demonstrably bad choice.
It really was. You would lose critical precision and execution speed. So Microsoft unambiguously wins on heavy math and raw execution speed. Turbo wins on development speed and price. But there was one specific benchmark where Turbo absolutely destroyed Microsoft, the sets test.
Yes, sets in Pascal are a specific data type, sort of like a collection of items. You can do unions, intersections, that sort of thing. Turbo handled the specific logic significantly faster than Microsoft did.
Why that one specific thing, though?
It likely comes down to how Borland internally implemented bit masking for that version. They found a very clever, very tight way to map mathematical sets directly to the CPU's bits. It shows that while the compiler wasn't doing global overarching optimization, the specific manual implementation of certain language features was incredibly tight.
Speaking of the language features, we really need to talk about the rebellion.
The Borland rebellion. This is where things get deeply philosophical about software design.
Because Pascal is a strictly defined standard, right? There is an ISO standard Pascal. It's defined by an academic committee. It is supposed to be exactly the same everywhere on every machine.
It is supposed to be, yes.
Did Borland actually follow those committee rules?
Borland looked at the giant rulebook, laughed, and completely threw it out the window. Bennett describes their design philosophy in the review as, use the standard, except where we don't like it.
Give me a concrete example of that. What do they actually cut?
So standard Pascal has commands called get and put. They are used for handling files, reading and writing. They're very academic, very abstract concepts. Borland essentially said nobody actually understands these. They are confusing. We are cutting them. They entirely replace them with read and write, which are vastly more intuitive for a normal human to understand.
But that entirely breaks portability, right? If I learn Pascal at a university using get and put, my textbook code won't even compile in Turbo.
Correct. Your code is instantly broken. They also completely cut procedural parameters, which is the ability to pass a function as an argument to another function. That is a fairly high-level computer science concept. Borland just said, it's too hard to implement fast in memory, so it's gone. They even ignored the page procedure entirely.
So they're essentially dumbing the language down.
They are streamlining it for speed and simplicity, but then they also added things. And the things they boldly added are what made Turbo Pascal an absolute legend among programmers.
The extensions.
First off, string handling.
Wait, didn't standard Pascal already have text strings?
Barely. In strict standard Pascal, a string was just a rigid packed array of characters. It was incredibly inflexible. If you defined a string variable as exactly 10 characters, it had to be 10 characters. You couldn't easily add two strings together.
But
Basic text processing was total agony.
and what did Borland do?
Borland copied the string handling model from UCSD Pascal. They introduced variable length strings. They added concatenation, so you could just add strings together with a simple plus sign. They added search functions. It made text processing incredibly easy. This is a huge reason why so many DOS utilities and text editors were quickly written in Turbo Pascal.
And then there's the direct hardware access. This is the dangerous stuff that academic Pascal actively tried to hide from you.
Yes. Standard Pascal tries to be a sandbox. It tries to protect you from the messy reality of the machine. It says, don't worry about memory addresses. I will handle all of that safely. Borland said, no, here's the mem array, here's the port array, go have fun breaking things.
Mem and port. What did those specifically let you do?
The mem array allowed you to read and write to any specific absolute byte in the computer's physical RAM. The port array allowed you to talk directly to the hardware ports, the internal speaker, the disk drive controller, the video card.
So you could completely bypass MS-DOS and the operating system entirely?
You absolutely could. And frankly, you had to if you wanted to write fast games or snappy utilities. You could write text directly into the video memory to make graphics pop onto the screen instantly instead of waiting for the slow DOS print routines. You couldn't do any of that in standard Pascal.
So Borland fundamentally took a safe academic teaching language and turned it into a gritty hacker's tool.
They weaponized it. They willingly sacrificed academic purity for raw, practical utility. And Bennett notes this explicitly. He says, these specific extensions make Turbo Pascal viable for actual systems programming, writing device drivers, writing memory-resident tools.
It's a huge trade-off, though. You lose portability. Your source code is now officially Turbo code, not standard Pascal code, but you gain the total power of the PC hardware.
And the software market voted with their wallets. The market loudly said, we don't care about the ISO academic committee. We want to write fast text to video memory. Borland decisively won that argument.
We are definitely painting a picture of a near-perfect piece of software here, but the screenless review is very honest about the specific flaws. We already talked about the weird dynamic tabs, but there are actual bugs in this release. Real frustrating bugs.
The type ahead white bug. This one resonates with me personally on a DUP level.
What exactly is it?
Okay, imagine you are a power user. You type extremely fast. The computer is busy doing something, maybe saving a file to the floppy, and you are already aggressively typing the next command because you know exactly what you want to do. Those keystrokes go into a keyboard buffer waiting for the CPU to catch up.
Right, type ahead. Very common.
Turbo Pascal 2.0 had a nasty bug where when it entered certain input modes for line editing, it would aggressively flush that keyboard buffer completely.
So it just deletes the keys I just typed out of existence.
Gone. You are typing a long sentence, the computer finishes its task, catches up, and half your sentence is just missing. Bennett calls it mildly aggravating. I would call it a compelling reason to smash the keyboard against the desk.
And there's also the underscore search bug. This one just sounds like a bizarre logic puzzle.
It is a fundamental parser disagreement inside the IDE. In programming, you very often use underscores in variable names, right? Like My underscore variable. The compiler properly treats my underscore variable as one single unbroken word.
Which is correct.
But the editor's find and replace function incorrectly treated the underscore as a space, as a word separator.
So if I open the search box and look for the word variable,
It would successfully find my underscore variable.
okay, that sounds somewhat helpful, actually.
Maybe. But if you specifically searched for my underscore variable, it wouldn't find it, because the search tool sees two separate words, but you are looking for one.
That is genuinely baffling. It means the integrated search tool doesn't even understand the syntax of the language it is supposedly editing.
It's a classic case of the left hand not knowing what the right hand is doing. It shows that even though it was an integrated environment, the integration under the hood wasn't perfectly seamless yet.
What about the documentation? Because learning a new tool in 1985 meant reading a physical manual.
A dense 300-page paperback manual. Bennett says it is a genuinely good reference book, but an absolutely terrible tutorial.
Like, here is what the technical command does. Good luck figuring out why you would ever actually use it.
Precisely. If you already knew Pascal from college, it was totally fine. If you were a beginner trying to learn, you were completely lost. And the example programs included on the floppy disk didn't help matters much. There was a famous spreadsheet demo program called Calc.
Wait, a working spreadsheet written entirely in Pascal?
Well, a toy spreadsheet. It was about 1,200 lines of code. Bennett actually tears it apart in his review. He points out that it uses global variables to control the local FOR loops.
Oof. For the non-programmers listening, why is that such a cardinal sin?
It is incredibly sloppy. If you use a global variable, meaning one that the entire program can see and change to count a local internal loop, and then some other random part of the program accidentally changes that variable, your loop just goes totally crazy. It is highly bug-prone. It is just objectively bad code hygiene.
So Borland was selling this revolutionary tool to help people learn programming, but they were literally including examples of bad programming on the disk.
Exactly. And the PALC program supported only 20 rows and 6 columns anyway. You couldn't realistically balance your checkbook on it. But, and here's the defense, it showed that you could write a complex interactive spreadsheet in Pascal. It proved the core concept, even if the actual code was messy.
So we have heavily covered the incredible speed, the disruptive price, the wild features, and the frustrating bugs. Bennett finally reaches a verdict at the end of his review.
And his verdict is simply outstanding.
Outstanding.
Despite the weird tabs, despite the rigid 64K memory limit, despite the non-standard language deviations, the overall value proposition is just undeniably too high. He calls it a robust compiler for small to medium projects. He acknowledges that it perfectly bridges the gap. It protects learners from the harsh reality of assembly code while giving them the raw execution power of the machine.
But he saves the absolute best observation for the very last sentence of the article, the final irony.
I love this part so much. Throughout the entire review, we have been heavily praising Turbo Pascal for letting us write in a nice high-level language. Don't worry about machine code, use-friendly Pascal.
Right, it is the ultimate tool of liberation for the programmer.
Bennett slyly notes at the end, quote, Borland apparently writes its products in assembler, unquote.
The tool used to free us from the pain of assembly language was itself entirely written in assembly language.
It absolutely had to be. Remember that tiny 50 kilobyte footprint? Remember that blazing 2,500 lines per minute compilation speed? You cannot get that level of performance by writing your compiler in Pascal. Philippe Kahn and his engineering team had to painstakingly handcraft every single byte of the Turbo Pascal IDE in raw machine code.
They literally had to deeply endure the suffering of the old way in order to build the new way for everyone else.
It was a true masterpiece of manual human optimization used to create a tool that famously did absolutely no optimization itself. It is beautifully poetic.
So as we wrap up this deep dive, I want to zoom out a bit. Why does a floppy disk from 1985 matter to us in 2026? We obviously don't use Turbo Pascal 2.0 anymore.
We don't use the software, no, but we absolutely live in the modern world that it built. Turbo Pascal proved once and for all that the developer experience matters just as much, if not more, than raw execution performance.
Right. Microsoft Pascal made faster programs, but Turbo Pascal made faster programmers.
Exactly that. It fundamentally shifted the bottleneck of software creation. The bottleneck used to be the computer's slow compilation time. Borland completely removed that bottleneck, and the new bottleneck simply became the programmer's human ability to think and type.
And it democratized the entire industry. It meant a teenager with $50 from a summer job could write the exact same caliber of software as a massive corporation.
That is its true legacy. The rise of the indie developer, the massive shareware boom of the early 90s. That entire culture started right here with this $50 disc.
I want to leave the listener with a thought today, a somewhat provocative thought based on all this.
Go for it.
We talked at length about that 50 kilobyte memory footprint, the entire IDE, the editor, the compiler, the environment running comfortably in 50K.
Incredibly tiny.
Today, I open a modern code editor. It's
Yeah.
not named names, but you absolutely know the ones I mean. It is built on web technologies. It routinely takes 4 gigabytes of RAM just to sit there empty. It physically lags when I type fast.
It really does. It's sluggish.
We have computers sitting on our desks that are literally a million times faster than that Sirius 1 computer Bennett used. And yet, are we truly a million times more productive as developers?
It is a very valid question. We have layered so much heavy abstraction, so much supposed convenience on top of our development tools that we have entirely lost that raw, instantaneous connection to the machine that Turbo Pascal offered in 1985.
Philip Kahn and his team figured out exactly how to give us absolute instant feedback over 40 years ago for $49.95. Maybe we should look at our current 4 gigabyte IDEs and seriously ask, what exactly are we paying for with all that massive overhead?
Are we actually coding faster now, or are we just waiting for slightly prettier progress bars to finish loading in much higher resolution?
Something to really think about the next time you're sitting there staring at a spinning loading icon waiting to test a single line of code.
Indeed.
That is it for this deep dive into the revolution of Turbo Pascal. A simple floppy disk that genuinely changed the software world. Thanks so much for listening.
Keep coding.